Welcome to the DIY Honda Garage channel. The DTC P0123 indicates a high voltage condition in the throttle position TP sensor A circuit. This code is pertinent to the Honda Accord models from 2012 to 2017, equipped with the K24W1 engine. The electronic throttle control system manages the throttle valve opening, involving multiple components like the throttle actuator, throttle valve, TP sensors A and B, the electronic throttle control system relay, the accelerator pedal position sensor, and the powertrain control module, PCM. Specifically, TP sensor A is a semiconductor type, located on the throttle body and connected to the throttle shaft, serving to relay the throttle valve position to the PCM. This feedback is essential for optimal engine performance, and a malfunction in this circuit can lead to various issues, triggering the P0123 DTC. In conclusion, DTC P0123 signals an issue with the throttle position sensor A, specifically indicating a circuit high voltage condition. A comprehensive understanding of the electronic throttle control system's components and functions is crucial for accurate diagnosis and resolution. By employing thorough inspections of the wiring and sensor outputs, technicians can effectively pinpoint the problem and implement necessary repairs. Moreover, preventive maintenance practices enhance the vehicle's reliability and performance, reducing the risk of recurring issues. Ultimately, addressing DTC P0123 expedites the restoration of optimal engine function, ensuring a safe and smooth driving experience for Honda Accord owners. DTC P0123 highlights a malfunction in the throttle position TP sensor A circuit. The affected component is TP sensor A, which measures the position of the throttle valve. This sensor plays a critical role by sending real-time data to the powertrain control module, PCM, enabling it to adjust the throttle actuator accordingly. Located directly on the throttle body, TP sensor A is integral to the electronic throttle control system that influences engine performance and efficiency. If the sensor detects a high voltage, specifically 4.8 volts or more for over 200 milliseconds, it triggers the PCM to store the DTC and illuminate the malfunction indicator lamp, MIL. This malfunction can prevent smooth acceleration, making troubleshooting essential. Several possible causes can lead to DTC P0123. First, a failure in the TP sensor A itself may cause incorrect voltage readings. This could arise from internal damage or wear. Second, the THL1 line or signal line for the TP sensor A might be open, meaning that there is a break in the electrical path that prevents proper communication with the PCM. Third, the SG line, another critical input for the sensor's operation, can be open, leading to similar communication failures. Finally, an internal circuit failure within the PCM can also cause the P0123 DTC, as the PCM may misinterpret valid signals or fail to process them correctly. Each of these scenarios necessitates thorough diagnosis to determine the exact issue. Symptoms associated with DTC P0123 can manifest in various ways. One of the most apparent signs is an illuminated malfunction indicator lamp, MIL, on the vehicle's dashboard, alerting the driver to a potential issue. Additionally, drivers may experience engine performance issues, characterized by hesitation during acceleration or unresponsive throttle behavior. This unresponsiveness may be particularly acute during rapid acceleration when the throttle actuator fails to adjust as needed. These conditions can lead to increased fuel consumption and decreased overall operating efficiency. Such performance degradation can also pose safety concerns, making it essential to address the issue promptly to restore normal function. The first step in troubleshooting DTC P0123 involves checking the integrity of the wiring associated with TP sensor A. Inspecting the connectors is crucial, as corrosion or damage can lead to signal interruptions. Ensuring that ground connections are intact is also essential, given that a poor ground can contribute to abnormal voltage readings. Any frayed wires or loose connections should be addressed immediately to safeguard against intermittent issues. Using a multimeter may help in verifying the resistance across these connections to ensure they are operating within acceptable ranges. A thorough visual inspection, coupled with electrical testing, sets the foundation for further diagnostic actions if initial checks yield no results. In the second troubleshooting step, the focus shifts to testing the output from TP Sensor A. This involves measuring its voltage levels while the engine is running and ensuring that these levels fall within the manufacturer's specifications, particularly under various load conditions. Using a digital multimeter can assist in accurately measuring the voltage output. Ideally, the TP Sensor A should output a varying voltage signal as the throttle opens and closes. If the reading is consistently high, exceeding 4.8 volts, this points to a malfunction within the sensor itself or potentially erroneous wiring. Documenting the findings during this test is crucial for further analysis and potential replacement of the sensor if it fails to meet specifications. The third troubleshooting step entails inspecting the powertrain control module, PCM, for internal faults. Utilizing a diagnostic scan tool can facilitate this process, allowing for the review of additional DTCs and live data, which can provide insight into the PCM's performance and functionality. Any discrepancies in sensor data or abnormal readings can indicate potential internal failures within the PCM. Furthermore, checking for software updates is advised, as outdated software could lead to communication discrepancies and erroneous DTCs being stored. It's essential to ensure that the PCM software aligns with the manufacturer's latest recommendations to avoid unnecessary replacement of components that could otherwise be resolved through an update. After completing repairs related to DTC P0123, the final repair verification should commence. First, clear any stored DTCs through a diagnostic tool and ensure that the MIL is extinguished. Following this, a test drive of the vehicle is necessary to validate the repairs and confirm that everything operates as intended. It's vital to subject the vehicle to various driving conditions to stress test the throttle response and ensure all related systems function correctly. After the test drive, recheck for any recurrence of the DTC using the diagnostic tool. If no DTCs reappear, it indicates successful resolution of the issue, confirming that the throttle control system is operating as per specifications. Preventive maintenance plays a vital role in avoiding DTC P0123 and ensuring the longevity of the electronic throttle control system. Regularly inspecting throttle components, including the TP sensors and their connections, can catch potential issues before they escalate into significant problems. Maintaining wiring integrity is particularly important. Routine checks for wear, corrosion, or damage can help prevent costly repairs down the line. Furthermore, engaging in periodic updates of the PCM software aligns the vehicle with the latest enhancements and fixes from the manufacturer. By investing in preventive measures, vehicle owners can enjoy smoother operation and better fuel efficiency, ultimately leading to a safer driving experience. Please like and subscribe to the channel. See you next time.